All right, happy Sunday. So the next unit is going to be released on the 11th. So I think I can close out this unit and be ready before the next one is released. So this unit is Unit 2.2, the Llama Index Framework. Last video, I finished the quick quiz. I actually got one wrong on the quick uh, quiz. I thought it was the case that a function name, a name, and a description must be defined when creating a tool. But not only was my answer based on what I learned in small agents, I think even for small agents, it's just recommended but not required. So the key, so we can see that the required word here actually is grammatically incorrect, or is actually the R is capitalized, even though that's not the correct way to write this sentence. So they make it very clear that the question is asking what is required. So the only thing that's required is the function. Yeah, so the name and description default to the name and docstring from the provided function. So this is when you create a tool, which is different from creating a function. Yeah, so that makes it make even more sense, right? Because um, yeah, when you create the function, there's different things that are required than when you create the tool. This question is not only about the tool, but it's asking for the things that are required. These are optional, but they're not required. All right, so let's move on to user agents in Llama Index. Remember Alfred, our helpful butler agent from earlier? Well, he's about to get an upgrade. Now that we understand the tools available in Llama Index, we can give Alfred new capabilities to serve us better. But before we continue, let's remind ourselves what makes an agent like Alfred tick. Back in Unit 1, we learned that an agent is a system that leverages an AI model to interact with its environment to achieve a user-defined objective. It combines reasoning, planning, and action execution, often via external tools, to fulfill tasks. Llama Index supports three main types of reasoning agents. Agents in Llama Index, function calling. These work with AI models that can call specific functions. React. These can work with any AI that does chat or text endpoint and deal with complex reasoning tasks. Advanced. These use more complex methods like LLM compiler or chain of abstraction, which is interesting. It's quite looks yeah. So that's a new one for me. I've heard of chain of thought, but I haven't heard of chain of abstraction quite yet. So function calling agents. These work with AI models that can call specific functions. React agents. These can work with any AI that does chat or text endpoint and deal with complex reasoning tasks. Advanced custom agents. These are more complex methods to deal with more complex tasks and workflows. For more information on advanced agents, so you can find more information on advanced agents in the Llama Index documentation, presumably. And yeah, so unfortunately I have a, oh man, that's annoying. Um, Let me whitelist that. Yeah, I have a very overly strict setup on my firewall, so I'm gonna whitelist that and try to move on. So I'll do this off camera. All right, I'm back. So I've whitelisted that in my firewall now, but unfortunately, in order to apply the changes, you have to reboot the firewall. I've had a lot of frustration with the pfSense ad blocker. Um, it's just there's an evaluation tool I've used that makes it seem like it's not even working. And then on top of that, like it seems to primarily do not much else besides um, make it more frustrating to use the internet. But next is initializing agents. You can follow the code in this notebook. You can run using Google Collapse. This is another notebook. So this I have doesn't require a whitelist. So let's get this taken care of. Okay. To create an agent, we start by providing it with a set of functions/tools that define its capabilities. Let's look at how to create an agent with some basic tools. As of this writing, the agent will automatically use the function calling API, if available, or a standard React agent loop. And I'll do a sound check, looks good. LLMs that support a tools/functions API are relatively new, but they provide a powerful way to call tools by avoiding specific prompting and allowing the LLM to create tool calls based on provided schemas. React agents are also good at complex reasoning tasks and can work with any LLM that has chat or text completion capabilities. They are more verbose and show the reasoning behind certain actions that they take. Agents are stateless by default. Add remembering past interactions is opt-in using a context object. This might be useful if you want to use an agent that needs to remember previous interactions, like a chatbot that maintains context across multiple messages, or a task manager that needs to track progress over time. You'll notice that agents in Llama Index are async because they use Python's await operator. If you are new to async code in Python or need a refresher, they have an excellent async guide. Now we've gotten to the basics. Let's take a look at how we can use more complex agents in our tools. Yeah, it's funny with Python because it's not, from what I understand, it's like not a code that can handle async very like by default very well. So like you have to add all this extra stuff in order to make it do async. So I'm actually going to read this article because I want to learn more about Python and async. And from what I understand, well, you know, let me not give my opinion of what async and sync is, because then I might have to unlearn. Then I might just be reinforcing misinformation, and I just want to read that and get my information from there. So I'll go off camera and plug in the token. All right, I am back. So let's try to run this code. We'll start by initializing an agent. So we're gonna import the, so we might have a problem here. We saw that this, unfortunately, okay, so we got to grant access to the variable, which we can see here. Now this is checked on where it was checked off before. But we've got a problem. Oh, you know what? It ran this time. That's interesting. I think last time we tried to run code like this Hugging Face Inference API wasn't working. It could be because I ran out of usage time. That might be what happened. But it's working now. We can see that with the check mark here. So that's good. So then we can run the agent and get the response and reasoning behind the tool calls. So we're going to get this RESP. See, we haven't run the agent yet. So yeah, now that we're trying to run the agent, we can see we have to pay to run the agent. Payment required. So we can look into that. We'll click on this and see how to pay, what the price is. So we can do explain error. And look at this. This is cool. An LLM will explain it. So we got a 402 error. So let's first look up what a 402. Yeah, so this is a 402 payment required error that you get from HTTP. So it requires that you, yeah, so I've exceeded the free tier usage limits. You know what we could probably do is maybe use a different model. That might do it. So we can actually add a prompt here. Oh, look at this. It says this is just that right away. Yeah, let's use a different model. Let's use one that's not going to bleed out the free tiers as quickly. So all we have to do is go back here, and instead of using Qwen, we're going to use a Google model. So just got to highlight this and hit Control C. Highlight this and hit Control V. Um, oh, which isn't working for some reason. That's okay. I can type it out. I'm not sure why that's not working, but luckily this model, in addition to being more friendly towards our free to use usage, it's actually easier to type out as well. Now this is where, if you're a network engineer like I am, this can get tricky sometimes. This is an L, not a one, I presume, but it could be a one. Okay, so that one for let's type a one just to see what the difference is. Yeah, so the one is shorter. It looks like it's a little bit thinner too at the bottom base, and then it angles down rather than angles forward. So welcome to the world of network engineering. You'll have to know whether it's an L or a one, and sometimes it looks exactly the same. All right, so now we got, oh, same thing, payment required. Wah, wah. So this one didn't work. I still have to pay for this agent, even though it is using a dinkier model. Yeah, I am out of free usage. Damn. Well, you know what I could do is I could run it locally. That would be fun. So what about running it locally? But I don't have my local. Yeah, so we need to install everything. We need to download LLM, which is going to take up a lot of space. We need to initialize it. We can use that with the transformers package. And then we need to modify the code here to use the local instance. So we could do that. I'm just worried. Yeah, I just don't have my local environment set up for that. So let's just move on. Yeah. So, well, that's too bad. So let's read this as just an aside to learn more about async programming in Python. I just wanted to learn more about that and then get back to it. So if you are new to async programming in Python, this page is for you. In Llama Index specifically, many operations and functions support async execution. This allows you to run multiple operations at the same time without blocking the main thread, which helps improve overall throughput and performance in many cases. Here are some of the key concepts you should understand. The basics of async IO, event loop. The event loop handles the scheduling and execution of async operations. It continuously checks for and executes tasks, coroutines. All async operations run by this loop, and there can only be one loop event per thread. Asyncio.run. This function is the entry point for running an asynchronous program. It creates and manages the event loop and cleans up after it completes. Remember that it is designed to be called once per thread. Some frameworks like FastAPI will run the event loop for you. Others will require you to run it yourself. Async plus Python notebooks. Python notebooks are a special case where the event loop is already running. That means you don't need to call asyncio.run yourself and can directly call and await async functions. Number two, async functions and await. Defining async functions. Use the async def syntax to define an asynchronous function coroutine. Instead of executing immediately, calling an async function returns a coroutine object that needs to be scheduled and run. Okay, so that's important to know because if you, it's not like a regular function anymore where you can simply call the function and the function will go. Now, since it's async, you create a coroutine object. So you call the coroutine object from the function when it's async, and then you can choose to either run now or schedule for later the run of the coroutine object, and then the code continues on regardless of whether you started that or not. It's async to the execution of the code rather than having to pause until that function has been executed before continuing. Using await. Inside an async function, await is used to pause execution of that function until the awaited task is complete. When you write await some function, the function yields control back to the loop event so that other tasks can be scheduled and run. Only one async function executes at a time, and they incorporate by yielding with await. Concurrency explained. Cooperative concurrency. Although you can schedule multiple async tasks, only one task runs at a time. This is different from true parallelism, where multiple tasks run at the same time. When a task hits an await, it suspends its execution so that another task may run. This makes async programs excellent for I/O bound tasks where waiting is common, such as API calls to LLMs and other services. Not true parallelism. Async I/O enables concurrency but does not run tasks in parallel. For CPU-bound work requiring parallel execution, consider threading or multiprocessing. Llama Index typically avoids multiprocessing in most cases and leaves it up to the user to implement, as it can be complex to do so in a way that is safe and efficient. Number 4, handling blocking synchronous code. Async I/O dot to TO underscore thread. Sometimes you need to run, and it's important to note too that there's a open and close parentheses after TO underscore THREAD. That signifies that you're running a function. You're calling the function. Sometimes you need to run synchronous blocking code without freezing your async program. Async.toThread offloads the blocking code to a separate thread, allowing the event loop to continue processing other tasks. Use it cautiously as it adds some overhead and can make debugging more challenging. Alternative, executors. You might also encounter the use of loop.run in executor to handle blocking functions. Number 5, a practical example. Below is an example demonstrating how to write and run async functions with async I/O. All right, so we can see you have to import async I/O, and now that it's imported, well, I think you don't have to import it. I think that async keyword is available whether you import it or not. If I go to Python, if I open up Python, I should be able to use async def my func. Yeah, so return hello world. Yeah, so I can do that without importing async IO, but async IO lets you to do special things with the function. So now you can use async IO to do special things with this with these built-in functionality of Python. If we do a help on async, uh, let's see if I spelt this right. So ASYNC. Let's do this. Let's do a help on myfunc because myfunc is a asynchronous function. Okay, so that's all we get is this. Oh, there we go. So if I go into the help menu and type in async, now we get help on coroutines. Cool. All right, quit out of that, and exit out of that. Looks good. All right. So creating RAG agents with query engine tools. Agentic RAG is a powerful way to use agents to answer questions about your data. We can pass various tools to Alfred to help him answer questions. However, instead of answering the question on top of documents automatically, Alfred can decide to use any other tool or flow to answer the question. Agentic RAG. I can do Agentic RAG if you provide me with a RAG pipeline tool and some other tools I could use to respond directly. So there we go. Okay, so I think these are the tools we're providing him. That's why it points to him. So we're providing him with this loop that we talked about. So the query, and the loop is going this way. So user queries to the index, prompt query, and relevant data to the LLM, and then a response. All right, then we're giving him the ability to search the web, ability to interact with external APIs, and the ability to provide a response. It is easy to wrap Query Engine as a tool for an agent. When doing so, we need to define a name and description. The LLM, we use this information to correctly, the LLM will use this information to correctly use the tool. Let's see how to load in a query engine tool using the query engine we created in the components section. All right, and I'll be back in just a little bit. I'll be back so soon I won't even need to pause the video. Okay, so here's the code that we can't run, unfortunately, because I don't have. I'm not willing to pay. I'm already paying too much for AI related things. Um, all right, so creating multi-agent systems. The agent workflow class also directly supports multi-agent systems. By giving each agent a name and description, the system maintains a single active speaker, with each agent having the ability to hand off to another agent. By narrowing the scope of each agent, we can increase their general accuracy when responding to user messages. Agents in Llama Index can also directly be used as tools for other agents for more complex and custom scenarios. All right. Haven't learned enough yet. There is a lot more to discover about agents and tools in Llama Index within the uh, Agent Workflow Basic Introduction or the Agent Learning Guide, where you can read more about streaming, context serialization, and human in the loop. Um, Now that we understand the basics of agents and tools in Llama Index, let's see how we can use Llama Index to create configurable and manageable workflows. So ideally, I understand that, but I didn't really go through the code very carefully because I can't run the code because I am broke. I'm so broke the code won't even execute. Ugh. All right, so enough of that. Moving on. Configuring agentic workflows in Llama Index. A workflow in Llama Index provides a structured way to organize your code into sequential and manageable steps. Such a workflow is created by defining steps which are triggered by events, and themselves emit events to trigger further steps. Let's take a look at Alfred showing a Llama Index workflow for a RAG task. Okay, so start event, you can pause query, collect input or setup. If you collect input, you get an input event. Similar for the other ones, setup event and query event. Then you run your query, stop event, done. Workflows offer several key benefits. Clear organization of code into discrete steps, event-driven architecture for flexible uh, control flow, type-safe communication between steps, built-in state management, support for both simple and complex agent interactions. As you might have guessed, workflows strike a great balance between the autonomy of agents while maintaining control over the overall workflow. So let's learn how to create a workflow ourselves. Creating workflows. And here's another notebook that I likely do not have, that I'm likely not able to use because of my free tier access. All right, so basic workflow creation, we would install the workflow package as introduced in the section on the Llama Hub. We can install the workflow package with the following command. We can create a single step workflow by defining a class that inherits from workflow and decorating our functions with this decorator here, which is the @ symbol STEP. We will also start to add start event. We will also need to add start event and stop event, which are special events that are used to indicate the start and end of the workflow. All right. As you can see, we can now run the workflow by calling w.run, connecting multiple steps. To connect multiple steps, we create custom events that carry data between steps. To do so, we need to add an event that is passed between the steps and transfers the output of the first step to the second step. All right. The type hinting is important here as it ensures that the workflow is executed correctly. Let's complicate things a bit more. All right, loops and branches. The type hinting is the most powerful part of workflows because it allows us to create branches, loops, and joins to facilitate more complex workflows. Let's show an example of creating a loop by using the union operator. In the example below, we see that the loop event is taken as input for the step and can be returned as output. So let's look for that decorator. Here it is. So the loop event is taken as input. Decorator is a function that takes a function as its argument. So it's going to take this async function and this loop event. So we can see the dynamic typing. So here's the, so first it takes self because it's a part of a class. So this is the namespace of the self. If we were to put something in the namespace of this class, it would also be usable in this function. That's because of this first argument self. Then we've got the EV variable. So we've got the dynamic typing to show what that is. So it's a start event, pipe, loop event, and remember that the pipe character is the union character. And then the output of this function is a processing event and a loop event. So, uh, so oh, is this an or? I'm just wondering why the. I guess I don't understand this because it's saying that the output processing event, and then I thought this was a join operator, so it has to be both. I thought, but it looks like it's if else. So, huh? Okay. Well, you know what would be really good is just talk about this with the LLM. Let's have a discussion about this block of code. I'm kind of confused what the pipe symbol is used for here. All right, and I'll be back shortly. Okay, I'm back. So, my password went in well. The simple workflow cell ran well. So, let's run. Yeah, so this is the. Oh, not quite. I think the next cell will be what we're discussing with the LLM. Yeah, this one. So let's see if this can run. Nope. Probably it did not pay. Ah, so this is interesting. There's actually no attribute intermediate result. So there's like a error with the code. Yeah, and we can see that intermediate result equals return processing of equals that. So this never, yeah, yeah. See, it never got defined. So I guess the else statement um, never got ran. Are there any errors? Let's ask it that. Okay, forget about that. Let's ask it that. Are there any errors in this code? Yeah, there are a few issues for sure. Um, oh well, it didn't see this stuff beforehand. Yeah. Now there's a logical error in step two. Let's see here. So yeah, this isn't going to be defined yet, right? Yeah, assume the event will always have. Yeah, exactly. Sometimes it won't have that. Yeah, you have to have this. Yeah, this intermediate result was wrong. All right, let's try this code instead. Ah, another problem. Oh, that's okay. We don't need these. Oh, okay. So now it works. Yeah, there was a problem with that code. All right. Well, moving on, drawing workflows. Okay, so you can also draw workflows. Let's use the draw all possible flows function to draw the workflow. This stores the workflow in an HTML file. There is one last cool trick that we will cover in the course, which is the ability to add state to the workflow. State management. State management is useful when you want to keep track on the state of the workflow so that every step has access to the same state. We can do this by using the context type hint on top of a parameter in the step function. Great, now you know how to create basic workflows in Llama Index. There are some more complex nuances to workflows which you can learn about in the Llama Index documentation. However, there is another way to create workflows which relies on the agent workflow class. Let's take a look at how we can use this to create a multi-agent workflow. Automating workflows with multi-agent workflows. Instead of manual workflow creation, we can use the agent workflow class to create a multi-agent workflow. The workflow uses workflow agents to allow you to create a system of one or more agents that can collaborate and hand off tasks to each other based on their specialized capabilities. This enables building complex agent systems where different agents handle different aspects of a task. Instead of importing classes from llama underscore index dot core dot agent, we will import the agent classes from llama underscore index dot core dot agent dot workflow. One agent must be designated as the root agent in the agent workflow constructor. When a user message comes in, it is first routed to the root agent. Each agent can then handle the request directly using their tools, hand off to another agent better suited for the task, return a response to the user. Let's see how to create a multi-agent workflow. All right, let's see if I can run this code. Grant access. Now this is probably, oh, agent workflow is not, so there's still errors in that. All right, screw it. Agent tools can also modify the workflow state we mentioned earlier. Before starting the workflow, we can provide an initial state dict that will be available to the agents, to all agents. The state is stored in the state key of the workflow context. It will be injected into the state underscore prompt, which augments each new user message. Let's inject a counter to count function calls by modifying the previous example. So we're going to get state. There we go. We're going to increment the function calls. Congratulations, you have now mastered the basics of agents in Llama Index. Let's continue with one final quiz to solidify your knowledge. All right, and this is just a quick ungraded quiz, so I can put this out here publicly. So what, another quiz, we know, but this short ungraded quiz is here to help you reinforce key concepts you've just learned. And this is active recall is one of the keys to learning. If you don't do active recall, you're going to give yourself the illusion that you've learned something without actually having learned it. So quizzes are a big part of active recall. This quiz covers agent workflows and interactions, essential components for building effective AI agents. Question 1, what is the purpose of agent workflow in Llama Index? To run one, okay, so what is the purpose of agent workflow? Okay, gonna go with A. Got it. So the agent workflow is the main way to quickly create a system with one or more agents. Oh, incorrect. So I got that one wrong. I think it's, oh, wow. Okay, wow. Um, okay, so wow, I got this one very, very wrong. So what object is used for keeping track of the state of a workflow? The correct answer is context. Context is the correct object used for keeping track of a workflow state. So you should be able to go back and look at that. Oops, and the browser is behaving randomly. It's not doing the same things it usually does when I press my keyboard. Okay. Ah, here we go. So this is the answer. Agents are stateless by default. Add remembering past options is opt-in using a context object. This might be useful if you want to use an agent that needs to remember previous interactions, like a chatbot that maintains context across multiple messages, or a task manager that needs to track progress over time. So that's a big one. I'm surprised I don't remember reading that. So definitely the answer was context there. All right, so question 3, what method should be used if you want an agent to remember previous actions? So you definitely need context. So I would say this one. Yep, by passing in and maintaining the context, we can maintain the state. It doesn't do it by default. And question 4, what is a key feature of agentic RAG? Uh, There we go. So Agentic Reg has the flexibility to use different tools to answer questions. And how does it do that? That's like magic. How does it know which tool to use? How does it decide which tool to use? I believe the answer to that is inference, but it hasn't. The training material has kind of left that a little bit unmentioned. But through my own conversation with the LLM, I think the answer to that is inference. So conclusion. Congratulations on finishing the Llama Index module of this second unit. You've just mastered the fundamentals of Llama Index, and you've seen how to build your own agentic workflows. Now you have skills in Llama Index. You can start to create search engines that will solve tasks you're interested in. In the next module of the unit, you're going to learn how to build agents with LangGraph. All right, keep learning and stay awesome. So I'm not going to give them feedback. I guess I could give them feedback about the error in the Python, but also, you know what? I'm going to give them a bit of feedback. So this would take me to gox.google.com, which is my whitelist doesn't handle, so that's annoying. I'm going to add that to my whitelist on my firewall. Um, so I'll do that off camera and end the videos. Thanks for watching and see you in the next one.